Okay, so first thing we're going to do, we're going to back up for just a minute and go back over square roots of integers raised to even exponents, because this is one thing that sometimes with the homework it gets a little bit confusing about exactly everything they're going to do. And again, this is only even exponents. Odd exponents, you don't have to worry about this because you can get negative answers if it's an even exponent that we're looking at with even roots, then, or square roots, then sometimes we get this one. That if you're going through these, and if you think about kind of what we're doing, and this is where you can almost take what we did in section 3 and kind of do some problems that were early on. Now, if we've got negative 3 to the 4th, that this is to the second power. But you could really write this as negative 3 to the 4 divided by 2 power. Be negative 3 to the second power. And then you can actually go ahead and do negative 3 to the second power. If you do negative 3 times negative 3, that would make the answer out to be a positive power. So some of these, when you start off with this, you may be thinking that the answer is going to have to be a negative when you go through these, but it's more of them just kind of working through some of these and seeing what you can get. It kind of works the same thing. If we have square root of negative 6 squared. And here's where it kind of changes directions on it a little bit. This one, they tell you to simplify, they tell you to find the square roots of integers raised to the even exponents. If you give it one like this, they're going to ask you just to simplify. And I mean, they're kind of getting a little bit tricky on these because of how they set these up. Because if you do the square root of negative 6, if you do this one, kind of like we did this one, you would do negative 6 to the 2 divided by 2 powers. You'd have negative 6 to the first, which would give you negative 6. If they ask you just to simplify, they actually want you to multiply out this number and go ahead and do negative 6 times negative 6, which will get you 36. And then you take the square root of 36 and get 6. So they get just a little bit tricky on these because the one part up here where they actually will tell you, take the square roots of integers raised to even exponents. They actually want you to kind of go through and do the parts we were doing. If they tell you to simplify, it's almost one of those where they want you to multiply out. To me, that's one of those questions where sometimes they're so similar that you have to almost test-wise pick one or the other. So we're not doing both of those. So when we get to the practice test, we'll kind of clarify exactly what we're doing there. But that's just one small difference that you may run into when you're going through some of these, that you may wonder, well, why wasn't this answer the same? Why wasn't it just a negative 6? Because these two square roots would cancel each other. I think it depends on the wording. So if you run into some of those in the homework, just bring them back in and we'll dig through it, and we'll make sure we got everything clarified before we get to the test on this one. Okay, so for 10.4, taking everything with the radicals, with simplifying and breaking them down. In 10.4, we're going to look at addition and subtraction. Okay, so the very first thing, basically you've got three things you've got to make sure and set up when we're going through this. First thing is the index has to be the same. And when we're talking about the index, that's the root that we're going to put on the outside. Okay, the second thing is the inside numbers. Which is the radicand has also got to be the same. And if you've gotten through the first two things, if either one of those two things is not true for number one or number two, there's nothing you can do. There's nothing you can do to add or subtract. But once these two things, if the index is the same or the root's the same, if the number that's on the inside, the radicand's the same, if those two things are the same, then you can add or subtract the numbers that's on the outside. So you're going to add or subtract the coefficients, which are just the numbers in front of the radicals. Now, the key thing on this one is the radicals don't change. So inside your radicals, that will stay the same. Now, here's kind of the first thing that you got kind of idea-wise. Before we do anything with radicals, that you could take it back to this part of it. That it's like 3x plus 7x minus 4x. That if you've got, again, you can almost think about this for the power almost being like the index. So you've got x to the first power, you've got x to the first power, you've got x to the first power. So the first thing is the index, which is, if we're doing just regular numbers, it would be like the power. They're all x to the first power, so the x's would all be the same. And once you got that, well, now you can just basically kind of ignore the variable part. And you can add the numbers. So you can do 3 plus 7 minus 4. And then you would just put the x on the outside. So 3 plus 7 is 10. 10 minus 4 will get you 6x. Okay, so they're trying to get you to think about just combining like terms like you would do in the past. Well, now the only difference is instead of it just being 3x, it's going to be 3 squared of x plus 7 squared of x minus 4 squared of x. So where you had just x to the first power, well, now we can almost think about it that we're doing x to the 1/2 power because it's square root, but we're just going to rewrite it in square root form. So these will be the problems that we're looking at. And if you have it where, again, we've got x to the first, x to the first, x to the first on the inside, they're all square roots. So then we can take the 3 plus the 7 minus the 4. And again, we're just going to put the square root of x at the end of it. So it's pretty much the same thing as combining like terms. Just the only thing now is instead of it just being whole number exponents, where everything was x to the first power back here, well, now we're looking at radical powers, where we're looking for the index for this number here to be the same. So we're going to do 6 squared of 14 plus 5 squared of 14 minus square root of 14. And the one thing that's kind of easy to sneak up on me on this one is, because we can do 6 plus 5 and make 11. But if you have this one, there's not a number in front, right? But you still have this minus 14 at the end. So when you have a number that's, or a radical that's there by itself, just remember that there is still 1 square root of 14 that's at the end of this one. This one we've got 6, this one we have 5, but then we're going to take away the square root of 14 that's by itself, so, but just think about it, there's a 1 in front of that one. So basically that's 6 plus 5 minus 1, and then we're going to put the square root of 14 behind it. So that would be 10 squared root of 14. Just to give you a little different look to it here. So let's do 12z third root of 2z minus 5z third root of 2z plus z third root of 2z. Okay, first thing is you're looking at is for the index. 3, 3, 3. So the indexes are all the same because they're all in the third root. And then the next thing you're looking for is making sure that all the inside numbers are the same. It's 2z, 2z, and 2z. So if all those match, then we're good to go. Now we can take the outside numbers and just add or subtract those. So we've got 12z minus 5z plus z. And then we'll go back and put the radical part at the end of it. So it's third root of 2z. Okay. And again, the only thing you have to really kind of be careful of with this one is making sure that, again, that if it's just the z, you still got to put a 1 in front. So it's 12 minus 5 for 7. 7 plus 1 would be 8z. And then we've got the third root of 2z that was the same, and it'll stay the same at the end. Okay, now here's one that sometimes it's almost, when you start gearing them up a little bit, and just go back and make sure. Sometimes you get one that's real easy, and sometimes it's easy to kind of split value. And so you have square root of 5 plus square root of 5. But if you have that, again, the only thing you really need to remember is that if there's not a number in front, just put a 1 in front. So technically it's 1 square root of 5 plus 1 square root of 5. So when you do the 1 plus 1, that would make it 2, and then your square root of 5 would sneak out behind the end of it there. Okay, now, one other thing we're going to look at is that if they happen to give you 1, and again, I don't think this would happen all that often. But just in case they try to get a little bit sneaky with you. It may give you something like this, where you're doing 4 times the square root of y. Plus 2 square root of x, and then minus 6 times the third root, or square root of x to the third. So if we're looking at the first thing is, they're all square roots, so for that part they're good. But if you start looking at what's on the inside, that one's y, that one's x. So those two are different, so there's nothing you can do there. You do have x here and here, but this one is x to the first power, this one's x to the third power, so those two powers are different. If they gave you one like this and asked you to simplify it, for the most part, you're pretty much done. Now, that's not going to happen in most cases. And what we're going to do next time is we're going to look at what will happen when they give you numbers. So variable-wise, they may do this one just to kind of give you a trick question. They may even kind of take you with this one, instead of having x to the third, they might even make it so it's t to the third. So if you've got 3 different variables, it doesn't matter what you do. There's no way you can take those and break it down, because one's an x, one's in y, and one's in t. So if they did happen to sneak one like this in on them, they should give you a button or an option in your homework that says it's already simplified. Now, test-wise, I'm not going to give you one like that because it's, to me, it's like a trick question. You know, if I'm going to give you something on there and ask you to simplify it, I'm going to ask you to break it down So I'm not gonna give you a trick question whether there's nothing you can do with it.